Hello, everyone. Welcome to the MicroLED Connect, our last session of this event, the OLED innovation and manufacturing. So now we'll be hearing from Dr. Rachith Shanivarasanthe. I hope I got it right. He's going to talk about plasmonic nanoparticles, which is a rather hot topic these days, and we know that several leading researchers and companies are looking into plasmonic as a sort of next generation OLED emitter design or platform. So let's hear it from Dr. Rachith. You can start.
Uh, Thank you, Ron. I hope you can hear me now. As Ron mentioned, my name is Dr. Rachith and today I'll talk about plasmonic nanoparticles and its application in OLED. Before I jump into the actual topic itself, I would like to introduce our group. I belong to a group known as Functional Materials Engineering, commonly known as Print Lab at U Hasselt, and our group is headed by Professor Bimde Fame. And as the name implies, we work on printing of health sensors. We work on stretchable electronics, structural electronics, and also we print light emitting devices. And in order to execute these applications, we do have sophisticated printing tools. And here I expertise on printing OLEDs and the ways to increase the efficiency of these OLEDs and near infrared OLEDs. In order to do so, I have already worked on incorporating plasmonic nanoparticles to increase the efficiency of OLEDs. I also have worked on plasmonic nanoparticles in perovskite PV to increase the light absorption. Currently, I'm also working on plasmonic nanoparticles for diamond electronics. And also, I have experience in various ultra thin film fabrication techniques, and also have invented two, new coating technologies to deposit ultra thin films over large area. Into the topic itself, I have divided my presentation into four simple topics: why and what are plasmonics, and how these plasmonic nanoparticles would help OLED community, and also where do we place these plasmonic nanoparticles. Finally, what are the fabrication tools we have to incorporate these plasmonic nanoparticles. Let me start with what is plasmonics. In simple term, plasmonics is nothing but the interaction of light with conduction-free electron on any metallic nanostructures or structures. And the question is, why do we have to, care about plasmonics as of now? As of 3rd of this month, already 34,000 articles as well as almost around 2,300 patents on plasmonics are either published or granted. That means a lot. So the most of the plasmonic application goes into the field of biology and as well as spectroscopy. If the field has significantly grown over the last few decades, it has to be due to the spectroscopy tools. And if spectroscopy can use it, then why can't OLED community? And the questions which I'll try to answer in few slides would be, as the definition says, for the plasmonics, they say the interaction of electromagnetic radiation with the conduction-free electrons. Is it enough to have the plasmonics? And what kind of plasmonics are we interested in OLED? So to answer the first question, we have something known as ingredients for plasmonics, and this could be negative permittivity of the material, which is mostly metals at optical frequencies, and the real permittivity materials, which are insulators, semiconductors, or even air. And we need to have light. And finally, oscillation of conduction-free electrons. When we put together everything, we'll have plasmon resonance. So to answer next question, what types of plasmons are we interested in OLED? It is basically, we'll be talking about localized surface plasmon resonance and surface plasmon polaritons. So what is localized surface plasmon resonance? Localized surface plasmon resonance, it's an interaction of light with small metal particles where it causes the electrons in the metal to oscillate, which creates electric field. Let me explain this. Consider a metallic nanoparticle. It could be gold. At certain, consider it as being oscillating at certain wavelength or frequency, and use a light at certain wavelength. If it matches with the wavelength or the natural frequency of oscillation of the metal nanoparticle, we'll have spectral overlap. When there is a spectral overlap, then we'll have the oscillation of the conduction free electron increases, and we call it as resonance. This will give intense near field enhancement over the plasmonic nanoparticles. This near field, we can use it for various application in OLEDs. And the second thing is surface plasmon polaritons. What are the surface plasmon polaritons? There is a small difference between localized surface plasmon and surface plasmon polaritons.